Hello everyone, my name is Arpit Saini and this is my submission for task 5.1p, Raspberry Pi GUI. In this task, I created a simple graphical user interface using Tincter in Python to control three LEDs connected to my Raspberry Pi. The GUI has three radio buttons, the white, yellow and green, and one exit button. When I select any color on the GUI, only that specific LEDs turn on while the others gets turned off. Hardware setup. Let me explain my hardware setup. I use a Raspberry Pi board with the following components connected on a breadboard. Three LEDs, white, yellow, and green. Resistors in series with each LEDs to prevent excessive current. I guess it is almost about 220 ohms. I'm sorry. And the jumper wires to connect the LEDs to GPIO pins. The connection are as followed. The white LED is connected to the GPIO pin 8 on the Raspberry Pi, and the yellow is connected to the GPIO pin number 10 on the Raspberry Pi, and the green LED is connected to the respective pin to the pin 12, GPIO pin 12 on the Raspberry Pi. So these all are the positive terminals which are connected to the GPIO pins, and all the negative terminals, the shorter leg of the LEDs are connected to the same ground rail on the breadboard. So when the program runs, the GPIO pins output high or low signals to turn each LEDs on or off.
Good morning, sir. My name is Arpit Saini, and these are some important libraries required for this task. After that, we are doing the GPIO setup by assigning the pins, and then we are running the loop for the LED setup and making the GUI so that we can see the button. When we click on the buttons, we can turn on and off the LED using the GUI.
So now let's talk about the how the code works. First of all, I imported the Tincter and RPA.GPI libraries. The Tincter used to build the GUI window, and RPA.GPI used to control the physical GPI pins on the Raspberry Pi. And then I configured the GPI mode and disabled warning. Here I used board numbering, which refers to the physical pin number on the Raspberry Pi. Next, I define LED pins and store them in a list. And coming down, I set each pin as an output and ensured all LEDs start in the off state. Yes, here, as you can see. And coming down there, and seeing up the GPIOs, I created a tinted UI window, and then the key function of the project is this one, and this function ensures that whether I select one LED color, the others are turned off. It maintains exclusive control. Only one LED can glow at a time. Next, I did added a radio button, radio button to control which LED should turn on. This whole and each radio button calls the turn on LED function which with the specific color parameter. When clicked, it automatically updates the LED output. Finally, I added a exit button. This one. Finally, I added an exit button to safely close the GUI and release the GPIO pins. This ensures that whether the GUI window is closed, all GPIO pins are reset and no LED remains on. So, in conclusion, this project demonstrates how a simple GUI can provide user-friendly control over physical hardware. It hides the hardware complexity and makes it easier to interact with embedded system visually. These concepts can be expanded further for projects like home automation, robotics control panels, or IoT dashboards. Thank you so much for watching.